Hello everyone, I'm Nick,
I'm Aaron.
and welcome to the Li Lab YouTube channel. Today, we're excited to announce the launch of the Li Lab whiteboard series. In these videos, we hope to offer introductions to key concepts and techniques surrounding the research we do in Li Lab.
In this first video, we're going to discuss the rollout issue that our research group and other research groups are trying to combat, global warming. For the first video, we're going to be going over how batteries actually function. Every year, we emit billions of tons of carbon dioxide in the atmosphere. If you look at the yearly CO2 emissions and global temperatures since 1850, we can see a clear link between the two. As we can see, average global temperatures have risen by about 1.3 degrees Celsius. This may not seem like a big deal, but this overall increase is unnatural, and our environment doesn't respond well to natural changes. Some bigger effects that we've seen from global warming are more severe storms, wildfires, destroyed ecosystems, and more.
This, of course, raises the question, if we're harming the environment so much, then why don't we just stop emitting so much CO2? Well, let's go through a short list. Fertilizer, transportation, plastic products, electricity. Each of these processes that allow society to function are actually powered by processes that emit CO2. Reducing the CO2 emissions in many of these areas with the technology we currently have is simply not feasible. Instead of this, considering the expertise of Li Lab, our studies of batteries can prove valuable to a major solution to this problem: electrifying transportation. Electrifying the transportation industry is one of the most rapidly developing solutions to lowering CO2 emissions. To explain, transportation accounts for 16% of global carbon emission due to the CO2 emitted by gasoline-powered vehicles. A number of brands, such as Tesla, have explored the possibility of designing electric-powered vehicles, also known as EVs. Currently, these vehicles operate on a lithium-ion battery, which is advantageous due to its rechargeability. However, another option being researched by the Li Lab is the lithium metal battery. With its much higher energy density, this battery can translate to a much longer driving distance.
Now that you've gained some insight on the impact of the research done in the Li Lab, let's talk about how batteries actually work. Have you ever thought to yourself, what exactly is electricity? How does plugging a cord into a wall turn on your laptop? How do batteries even store electricity? To fully understand this phenomenon, let's first look at the chemistry. Electricity itself can be thought of as a flow of electrons. As we see in everyday life, batteries are objects that can store electricity. Therefore, they act as storage units for electrons. These electron storages consist of two main components: electrodes and an electrolyte. The electrodes consist of an anode and cathode. The anode is referred to as the negative or oxidizing electrode, whereas the cathode is referred to as a positive or reducing electrode. Notably, these negative/positive descriptors actually refer to the voltage difference between the electrodes. However, for our purposes, they can be thought of as the state of each electrode while the battery is fully charged or discharging. This being said, the negative anode stores the transportable electrons in a charged battery, and the positive cathode is where the transportable electrons reside when the battery is dead. The liquid electrolyte ties the system together, allowing lithium ions to pass while rejecting the flow of electrons. Many batteries also have a separator, and it makes sure that the anode and the cathode don't come in contact to prevent the system from exploding. Batteries also have current collectors, and these help with transporting electrons from the electrodes to the device that needs electricity, such as a phone or laptop.
Now let's imagine putting a fully charged battery into a device. This device can act as a circuit, meaning that it can link the anode to the cathode with a path navigable by electrons. When the battery is fully charged, there is an abundance of electrons in the negative anode and a deficiency of electrons in the positive cathode, encouraging any available electrons to mosey from the packed anodes to the more inviting cathode. However, the electrons can't travel directly to the cathode because they are unable to flow through the electrolyte, as aforementioned. Thus, when a battery is plugged into a device, it acts as a path through which the electrons can travel, supplying the device with an electronic current. Consequently, as the anode releases these electrons, it also needs to release positively charged ions simultaneously to remain neutrally charged. In the case of a lithium metal battery, the lithium metal of the anode releases positively charged lithium ions that travel through the electrolyte to the cathode in order to flow with the associated electrons. A battery is then dead when all of the available energy is transferred from the anode to the cathode. If we then flip this process, when recharging a battery, you can simply supply an electrical flow to the anode. This will return the lithium ions and associated electrons to the anode, recharging the battery for later usage. Ideally, we would be able to repeat this process forever, discharging and recharging to our heart's content. Unfortunately, real life sucks, and this circulative process is not 100% efficient, as batteries will actually degrade over time, being repeatedly cycled. This degradation of the battery can be attributed to many factors, such as the lithium dendrite growth, but those issues can get really complex, so we will save the discussion for another video.
As we mentioned before, lithium metal batteries can deliver significantly more power compared to lithium-ion batteries.
However, they still struggle due to their extremely poor rechargeability and potential as a safety hazard. The focus of the Li lab is to apply many techniques used by scientists and engineers to uncover the inner workings of these batteries, and to do so at an ultrascopic scale.
If we are able to develop a complete understanding of the interactions occurring within a battery, we could potentially discover new design methodologies to improve battery design for the future to come, allowing us to progress society towards a future of cleaner energy. In the next video, we'll dive more into the shortcomings of the lithium metal battery and what's currently preventing scientists from commercializing this technology.
We hope you learned a thing or two about how batteries work and its role in helping with reducing climate change. If you are still here, thanks for watching the whole video. Type any questions you have in the comments, and one of us will be sure to reply. And as always, if you enjoyed it, don't forget to like and share the video, and maybe even subscribe for more content in the future. Bye!